Okay. Hi everyone. We're just waiting for another minute. Make sure someone a bit late for webinar, and we will be start really shortly. Yeah. You can use a chat in the webinar section in the right hand side for asking questions. Yeah, I like to say ready to start. Okay, hi, welcome to Zometry webinar. Today we want to talking about it 5 ways to reduce CNC machining cost with a better design. My name is Attila Szűcs. I'm an application engineer at Zometry, and here with me Dorian Sarsby. He's a key account manager also in Zometry. Today our agenda, obviously better design equal easier manufacturing and cheaper parts. So I got 14 years hands-on experience on CNC manufacturing. I start on working on machines, 5-axis simultaneous and simple 3-axis, 4-axis machines, also turning, milling turning, and I got hands-on experience on EDM, wire roding, and a little bit sheet metal CNC as well. I got experience with CAD/CAM programming, multiple CAD/CAM software I use in my past career. I work in different industries as aerospace, motor industry, medical, robotic, and motorsports. So I like to use my knowledge for sharing my thoughts about design, small design changes, which could save you money, lead time, and literally just easier for manufacture. I'd like to ask Dorian, please introduce yourself as well.
Thanks, Attila. So my name's Dorian Sarsby. I'm one of the key account managers here in the UK. I've been working with Zometry for 2 years now and have over a dozen years of experience in manufacturing across many different industries. So I'll be here on hand to answer any sales-related questions that you may have. And I'd just like to say, yeah, feel free to leave any questions in the chat area on the right-hand side, and I'll try to answer them as we go along or at the end with a Q&A session with Attila. Thank you very much. Back to you, Attila.
Thank you. I just want to add on there on the end the technical questions I try to answer over the agenda. I like to going through with it. So today we're gonna be talking about it, adjusting your design to standard machining tool. So basically, what's the standard tool for CNC machining? What need to be aware of it? Thinking about work holding when making a design. So what kind of two simple or standard way they make in hold your part and how you need to think in when you make your design. And feature that are hard to and expensive to manufacturing. So when you doing some kind of extreme features, why it's difficult to manufacture. Hold tolerances impact your cost. Why is a tight tolerances cost more than looser tolerances. And how you prepare your 3D model for any other machining like CMM, CNC or CAD/CAM software. Why is need to be what kind of file format you want to push it out. And on the end, I like to show a little demo. I make it some little models which is shows what could be used in our instant coating engine at Zometry, and presented what I'm talking about through this presentation is how much money could be saved for you and your parts. So let's jump on it. First thing, as I say it, is how you adjust your design to standard tools, standard machining tools. So two basic standard tools we can identify. One of them is a flat bottom end mill, and other one is a bow nose. Flat bottom end mill is, as I said, it's got a flat bottom. It's really good for flat surface, pockets, slots, any kind of two-dimensional features like bigger holes or different kind of slots, pockets. Bow nose end mill, as in saying in the name, it's got like a full radius on the bottom, and it's good for 2.5D or 3D surfacing. Actually, if you got like a ball or like any kind of 3D surface, they use this kind of tool. So when you see the tool, the CNC tools is literally a round tool. So really difficult, basically impossible to make sharp corners with a round tool. So if you require your design required sharp corners, in that case, you need to add on extra manufacturing process, for example, EDM or wire rolling if you're talking about, let's say, a through pocket. So when we're saying is a round tool only can cut round corners, the minimum is at least a 0.5 millimeter radius. If you think in a 0.5 millimeter radius is a 1 millimeter diameter tool, which is a really small tool, and it's still doable, but it's time consuming. So try to increase your corner radius as much as big as is possible. The reason why they can use bigger radius equals bigger tool you can use, which means they can hit it harder, they can push it harder, they cut in quicker the material. So that could be save you significant much money if you just add on a slightly bigger radius. CNC tool have a limitation on cutting length. Typically, they work with the best when cutting cavities with a depth of 3 times of a diameter. So if you think in creating features, good if you know it is like usually whatever radius put it in a corner, obviously times it as a diameter and 3 times of a depth. That is the best way. If you can increase it, that depth is still doable, but is in that time is identified as a special tool, I would say. Highly chance, obviously above 3 times, is starting vibration and start getting a vibration on the walls. So what it needs to be happened, slow it down the manufacturing, slow it down the cutting speed, and have to take multiple steps, which is extra time and extra money. So basically, these are tools, these two tools, what they usually use on CNC manufacturing. After that, when we know about tooling, let's talk about it, how you're gonna behold that part, basically. So adjust your design for work holding. Two basic work holding, as I mentioned earlier, the vise and a complex part when you're making fixtures. So vise is one of the most simple, most quickest way to hold in your parts. Basically, they on a CNC table, they got these wires clamped it down on the side, and simple as that. It just need to have your model, your parts, at least 2 parallel faces for hold it. But negative side of that, as you can see on the right hand corner picture, I try to present it as like a holding force if you got like thin wall or not as strong material, let's say, as a titanium, obviously stronger. If you got like a weaker material, some kind of plastic, is easily can be bent. So, and another negative side of it is got like size limitations. And if we're talking about it, high quantity parts is quite manually change one by one, which is not the most efficient way. So what happened if you got like a complex surface, let's say a like hand, which I make it in a design. Obviously, as you can see, no parallel faces, no square area. So in that case, usually they have to create a fixture. With a fixture, you need to think in as a programmer, need to create a model, and that model needs to be manufactured as well, and is obviously taking time, taking a knowledge, and basically that time is money, as simple as that. So how you can thinking about when you design a part, you can add on through holes, tap holes, or actually clamping areas, flat areas, which is helpful clamping down your part. As you can see, I try to present it some little pictures in a right, left, right down corner. In edit some kind of tap-in hole, which is can be pulled back on that, and it's got enough strength for holding your part. So what other features is making more expensive the design? Let's jump on it. So adjust your design to simplify manufacturing. If is possible, try to simplify your design as much as possible. If you see a right up corner as diamond shape, that is one of them most complex part you can think of. Not just because of work holding, because it's every single face is a different angle. So usually a 3-axis machine or 4-axis, 5-axis machine, they only can machine in amount of size, and each machine inside need to be set up in a different angle. So each face is a separate operation. Each feature on different angle is a separate operation. If it's possible, try to minimalize a face, minimalize these features, individual sizes. And in that case, less operation, less setup time, less programming time. So other easier way you're thinking saving cost. If you technically cut it less, if you machining to make it less waste of a material. So try to have a look at standard material sizes, whatever material choose you have, aluminum, stainless steel, mild steel, and you'll make your design as close as possible to that kind of standard material. In that case, you limited the waste of a material, limited the cutting time, which is obviously saving money. The main problem I like to talk about, obviously, the thin walls. Up to like 2 millimeter thick thin wall is technically doable, but when you're getting smaller, is the biggest issues came up, the vibration. So I have to do multiple steps and slow it down your tool and slow it down your speed. Make sure this surface end is not going to be pushing away these thin walls. It could be easily bended and reduce actually a tool life as well. So what could be a solution? Adding a massive radius on the bottom, and also you can add a support wherever you can, because that support is making significantly stronger and reduce the vibration chance, which is one of them obviously biggest enemy on a CNC. So if you're thinking now, we talk about basic tools, we talked about it, basic work holding. Now we got a part as well. What else is left? how you're gonna do your tolerances. So adjust your design to drivers of the tolerance. I like to say try to use general tolerances as much as is possible. Bigger general tolerance hugely change the manufacturing. I just want to say one simple example. For example, you got a hole, and that hole is a general tolerance is plus or minus, let's say 0.2. A standard manufacturing process, you drill it. As simple as that. But if you put it tighter holes, let's say a H7, which is like 0.01 plus, in that case, you have to add on a reamer and you have to do a pre-drilling, which is, again, if you're thinking for same hole, you have to add on more process, more tools, which is more cost. So please think about it, your application. What kind of function is gonna be? Is gonna be a loose fit area or free fit or press fit? It's actually got like, I don't know, thermal or mechanical deformation in there, or just dust or any kind of environment which is gonna be affect these sizes. So if you over tighten without no reason and you're thinking like even just the temperature, because it's metal, could be increase or decrease, and is technically just a bit warm environment could be out of tolerance, in no point to tightening up. In that case, you can save a lot of more money. I like to point it out in any kind of surface treatment like anodizing, rock hardening, try to present it on your drawing is these sizes, these tolerances is before or after this kind of surface treatment you want to be seen. So if you're thinking like a tight tolerance and they're going anodize, and this anodize is actually thicker than your tolerance, will be saving a time for conversation as well, or less chance to make the CAD/CAM programmer a mistake for how you're manufacturing your part. So make sure you try to present on your 2D drawing. And on the last thing I like to say in here, try to accounting for tolerance slack. So tolerance slack is a total maximum or minimum tolerance of a specific dimension or measurement. So you got like a big assembly part, and around your part is nothing else, for example, just fresh air. And it doesn't really much matter if it's plus or minus 0.01 or plus or minus 0.5. Try to leave it as big as possible, and easily can save lots of money. So obviously we're done now with the drawing side as well. We've done a holding, we've done a model, done a tool, whatever left. Basically how you like to, your final model, how you like to be present for less mistake you can make with it as a production engineer. So adjust your design for 3D file for manufacturing. Adjust your 3D file for manufacturing. First thing I like to say, assure the solidity of your model. All the points, curves, lines, surface, any vertical or connected in the object are created only for close shapes. So make sure there's no unnecessary surface or like going through some of them features, and is make it impossible to manufacture. And most of the time they have to send it back, and it's so much wasting time, especially when you got like a tight lead time or tight production time. These communications will be saved if you do as from a beginning the tighter solidity model. Another common issue I faced in my career is size matching. So special in sheet metal work, when you got a DXF file, is a 2D drawing file, which is they use widely on sheet metal working. Make sure that is 1-to-1 size. Otherwise, is accidentally they can create it so much different size of material, different size of part as you expected. And yeah, just try to 1-to-1. Another important things on your 3D model is modeling to mid-limit. I understand when you model something and after that, oh, okay, let's figure out what kind of tolerance is there. So you don't want to be smaller, but you can be bigger. And after that, you just don't want to change your model. But issue with that, the CAD/CAM softwares, the CAD/CAM programmers, they're going to be use your model for manufacture that part. And probably in that case, they're not going to be checking 100% the model sizes. So they're creating a part after they're going for first article inspection or like a standard full check-in of any kind of CMM check-in. And that time they realize, oh, something is top limit, something is bottom limit. So they have to going back on a CAD/CAM program. They have to adjust your model, have to redo in your a programming and remake it the manufacturing. So this kind of time is obviously a waste of time, which is can be done on a beginning of a modeling. It's quite important for, and also maybe they missing something and just chance for mistake. And last but not least, I like to talk about what kind of format I should push it out. So STL is more likely good for 3D printing, but not really good for CNC machining because it doesn't store enough data about the surface, about the sizes. And if you want a precise part, is simply just don't have enough data on a STL file for make it a good precise part. So if you can please use a step file, ISO step file, which is widely used almost everywhere in a CNC software or CMM or CAD/CAM program software, and never ever have any software which is couldn't read step file, to be honest. And I know some of them branded files is good because store more data, but in that case, some of them CAD/CAM software have to buy extra license for reading this kind of file. Just bearing in mind. So more widely used step file, I think, is the most easiest and simple way. So now I like to talk about it a bit. Xometry, which is an on-demand manufacturing website, is saving so much pain for looking provider or like saving lots of time because it's three simple step. You just upload your parts, you get an instant code and click and buy. And a code actually a matter of a second you can get it. And basically as you usually I'm not sure what usually if you think in a standard manufacturing when you see when you want to have a quote, it's taking like, let's say 3 to 5 days normally, which is a week of working you can save just with our IQE engine. I like to show my demo currently. Just bear me a minute. I share my screen. So as I mentioned earlier, I created 2 models. So when you go in on Xometry website, you got like a simple area which is you can load in up any kind of file, and you got like another area which is your previous code. I loading up for file is easy. Just click on browse or drag and drop much file as you can. I currently, sorry about that. I just drag and drop. As you can see, it's 2 files. One of them actually with a 2 mil radius of a pocket, other one with a 4 mil radius of a pocket. I just simply click start quoting. And in here, as you can see, the IQE algorithm is analyze these models, taking bullet points, which is checking what kind of price could be their part. And just matter of a second, really, doing that. As I mentioned earlier, is got just it's basically exactly the same part. It's both of them 50 by 50 by 50 block and just a R2 radius. So you have a look, it's automatically give it to me a CNC machining, aluminium. So if I want to edit specification, you just click edit, and you can select it all different kind of manufacturing process in here: CNC, sheet metal, injection molding, die casting, around 15, and all different kind of 3D printing, around 15 different kind of manufacturing process got in our data, and around like 100 different kind of material in our database. If it's something here which is not specified, you can use a custom area. So as you can see in the right hand side, you got like a 3D viewer. I just want to show again. In these corners, as you can see, I got 2 mil radius. Another thing I like to talk about it, which is could be save for you a bit pain. Some designers like to do a tap hole, design it and model it, which is unfortunately in that case it came up as a feature. So thinking as like an undercut, the CAD/CAM software is not really like to read it. I like to suggest if you can put it as core diameter of the thread and try to present it as a 2D drawing. What kind of thread is that? Because this pitch is not going to be readable from the model. So you got like a certain area, you can put it different kind of finishes, as I talked about earlier, anodizing, for example, different kind of tighter tolerances. So I want to put it, because we got one hole, one extra tap hole. In the meantime, is automatically calculated as well. And obviously, because I say we talk about tap hole, they required drawing as well. So if you don't have a drawing uploaded yet, just drag and drop here, and it's uploaded to this part. Second part has the same things. I like to show again just for clearance. Only thing is changed is the radiuses in the corners, and I take off the model it tap hole. It's just a core diameter. So from 2 mil to 4 mil, and I change it, actually add on a thread, because it's extra calculation point, extra bullet point for our IQE. Make sure we get a better calculation price, or more accurate price. Again, ask in a drawing. If you're interested for one-off, obviously one-off is always more expensive because setup time, programming time. But if you're interested, okay, my yearly use is over like 500 or 200, and how much could be a price? You instantly gonna be having. So it's a quite nice feature. I'll leave it one for now, and just for showing how much is a price different. So with a 2 mil red, we got like 96 quid and a bit. And with a 4 mil red, we got like almost £80. And you can see it's around, we're talking about 20% saving just for a small feature change. Yeah, I just stop sharing my screen. Yeah, thanks for your attention. Now I think we're ready for question and answers. Dorian, are you with me as well?
Hi, Attila. Yeah. Thanks for showing us that. Really, really interesting, really useful. So we do have a couple of questions that I'd just like to roll back to. So a question from Oliver. Hi, Ollie. He was asking whether.
Hi, Oliver.
Yeah, he was asking whether question regarding file formats, whether parasolids can be used for CNC machining as well, such as a .x x-t file.
Yeah.
I think these are typically used for 3D printing, but I'll let you answer this one, please.
A parasolid also can be used CNC manufacturing, is also a good file. Only issue with that, I think some of them CMM software is not happy to use. So I'm not 100% sure, but as far as I know of, sometimes they got struggle with parasolid. So obviously you can make it apart, but you couldn't do a precise check, and we need to transfer. Yeah.
Cool. Thanks. Yeah, thanks for that. And next question was from Anthony, and it was regarding modeling to the middle limit. He was asking, what do you suggest is best practice for the situation when the feature is to be dimensioned as 0.xx minus 0 stroke.
I understand what you want to ask.
Yep.
So it's like
and
minus
this one was answered
plus,
by Ollie,
let's say 1 mil.
Yeah.
So minus nothing plus something, or plus nothing minus something. Way. In that case, again, the same things. Whatever size you model it is, that model try to make it, and this so many times is an issue. So you add, let's say in that case, plus 0.1 or plus 1 mil for easier talking, and minus 0. It try to be model it 0.5 as plus, because you imagine if we're talking about multiple surfacing, and that surface is not going to be matched, whatever requirement you have. And issue with when you CNC manufacture something, always try to make it the first one is mid limit, because over the time when you make it like 10 parts, 100 parts, then start wearing a tool, start warming up a machine, is slightly moving up and down. Obviously, tolerances never can do exactly the same, like, I don't know, 100 times. So yeah, it try to all the time model it to mid limit. I know it's a pain when you're thinking like minus nothing and plus 1 mil, but in that case, I would say someone have to done it, unfortunately. And if a CAD-CAM programmer do it, is not as educated than a designer, or can't see a full assembly, and just easy to make mistake.
Excellent, thank you. And then the next question is from Padmanabhan, and he was just saying that his connection had interrupted and that he'd missed the 4th step. So I think perhaps rather than going over it all, the actual presentation or webinar is going to be recorded. So what we can do is we can share that with you, Padmanabhan, on email, if that's okay. Someone else is typing, so we'll just hang on for the next incoming question. Cool. Well, good. So we've got another question coming through. Can we share the recording with everyone? Yes, we can, Ollie. We'll send it out to everyone after the webinar. You're welcome.
You're welcome. Any more questions?
Any other questions? So whilst we're just waiting for some questions to come in, and for those of you that are still with us, I just wanted to say that I'm not sure if you noticed, but as a special bonus for attending the webinar, we have provided you with a 5% discount code to get you started and get you. It's essentially a great way to trial out the Xometry and our instant quote engine to see how the platform and the service works. Yeah, on your first order. Or for those who have already used us, it's a nice way to get some discount off your next order. So. I think that's perhaps it for questions. So yeah, I'd just like to say, yeah, thanks for attending the webinar. Yeah, Xometry, we're the largest manufacturing on demand supplier in the world. So not just here supporting you with CNC parts, we can support you with prototype through to series production. From any quantity, from one-offs to many millions of parts per year. So if you don't have any further,
also,
yes, go ahead.
And also if you got like DFM help, you need DFM help, is our engineers, included me as well. I'm here for help any of you for making a better design as we're talking today.
Yeah, so that's a great point, Attila. So we've got one of our value-added services is that we can offer you DFM support to optimize your parts to suit any of the technologies, 15 technologies that we run. So if you do have any questions or require any support, please do feel free to reach out to either Attila or myself directly, and we can get that set up for you. Yeah, I'd just like to say again, thank you all for attending. We'll
Thanks
get
for
a
your
copy.
time.
Yep, we'll get a copy of the recording out to you, where you'll have our contact details, and yeah, we look forward to working with you in the future.
Thank you.
Thank you.